Lieutenant Yasunori Aoki gripped the control stick of his Mitsubishi A6M Zero fighter as he approached the target area at 0615 hours on April 6, 1945. Below him, the waters around Okinawa should have been filled with the massive American invasion fleet that intelligence reports had described, hundreds of vulnerable transports and cargo vessels providing easy targets for the Special Attack Corps. Instead, Aoki found himself facing something unprecedented in his experience as a kamikaze pilot, a defensive arrangement that challenged everything Japanese tactical doctrine had taught him about American naval operations. The Divine Wind Special Attack Unit had been formed with a single, desperate purpose. Japan's conventional air forces had proven incapable of stopping the methodical American advance across the Pacific, losing thousands of experienced pilots in battles where superior American aircraft, training, and technology created insurmountable disadvantages. The kamikaze represented Japan's final tactical innovation, trading pilot lives for guaranteed hits against enemy vessels that conventional bombing could no longer achieve. Aoki had volunteered for the Special Attack Corps with the understanding that his death would serve the Emperor and the Empire in its hour of greatest need. His training had been minimal by traditional standards, just enough flight instruction to enable him to guide his explosive-laden Zero into the hull of an American warship. The aircraft carried a 250-kilogram bomb in addition to its normal armament, transforming the fighter into a guided missile that American defensive fire could not deflect once the pilot committed to his final dive. But as Aoki searched the waters around Okinawa for the concentration of enemy vessels that should have provided unmistakable targets, he encountered instead a defensive system that Imperial Japanese Navy planners had not anticipated. Spread across the approaches to the main fleet were individual American destroyers, positioned at distances that extended far beyond the normal protective screen that Japanese intelligence had observed around enemy task forces. The radar picket destroyers represented a revolutionary American tactical innovation that combined advanced electronics with aggressive defensive positioning to create early warning networks that detected incoming attacks while they were still hours away from the main fleet. 16 radar picket stations surrounded Okinawa at distances ranging from 18 to 95 miles from the primary invasion forces, each manned by destroyers equipped with the most advanced air search radar available to the United States Navy. Commander Frederick Beckton, commanding USS Laffey at Radar Picket Station 1, understood that his destroyer was being used as an expendable early warning system designed to absorb the first impact of kamikaze attacks while providing the main fleet with crucial intelligence about incoming raids. The tactical doctrine was clear: radar picket destroyers would detect, engage, and if necessary sacrifice themselves to protect the high-value targets concentrated around the invasion beaches. The SK air search radar aboard Laffey could detect incoming aircraft at ranges exceeding 100 miles, providing American forces with warning time that eliminated the element of surprise that kamikaze tactics depended upon. Previous Japanese suicide attacks had achieved success by approaching American fleets undetected, allowing kamikaze pilots to select optimal targets and attack from favorable angles that minimized exposure to defensive fire. The radar picket system eliminated these advantages by detecting kamikaze formations while they were still far from their intended targets. American fighter aircraft could be vectored toward incoming raids, engaging kamikaze pilots while they were still flying in formation and before they could begin their individual attack runs. The early warning provided by radar picket destroyers transformed kamikaze attacks from surprise assaults into extended air battles that favored American defensive capabilities. Lieutenant Aoki received his first indication of the radar picket system's effectiveness when his formation was intercepted by American F-6F Hellcat fighters 50 miles from Okinawa, far from any visible American vessels. The interception demonstrated coordination and timing that required advanced radar detection and fighter direction capabilities that Japanese intelligence had underestimated. Previous kamikaze missions had encountered fighter opposition only after approaching close enough to enemy fleets to be visually detected. The early interception forced Aoki's formation to engage in defensive maneuvering that consumed fuel and reduced the time available for target selection once they reached the American fleet. Kamikaze pilots who survived the fighter interception arrived at their target area with damaged aircraft, reduced fuel reserves, and the psychological stress of extended combat that affected their ability to execute precise attack runs. When Aoki finally broke through the fighter screen and approached what appeared to be a lone American destroyer positioned far ahead of the main fleet, He assumed he had found an isolated target that could be attacked without interference from concentrated defensive fire. The tactical situation seemed ideal for kamikaze attack, a single vessel without the overlapping anti-aircraft coverage that protected larger American formations. But USS Laffey represented more than an isolated destroyer. The vessel was equipped with defensive systems that incorporated the most advanced anti-aircraft technology available to the United States Navy. Twin 5-inch dual-purpose guns could engage aerial targets at ranges exceeding 10 miles using VT proximity fuses that detonated automatically when shells approached within lethal distance of enemy aircraft. The technology eliminated the need for precise range calculation and timing that had limited the effectiveness of conventional anti-aircraft fire. The proximity fuse represented a scientific breakthrough that revolutionized anti-aircraft warfare by incorporating miniaturized radar transmitters into artillery shells. Each 5-inch projectile carried its own detection system that measured distance to targets and triggered detonation at optimal range for maximum fragmentation effect. The technology was 7 times more effective than conventional time-fused shells, transforming anti-aircraft guns from area denial weapons into precision aircraft killers. Commander Becton opened fire on Aoki's Zero at maximum effective range, using proximity-fused shells that created lethal airbursts without requiring direct hits on the small, maneuvering target. The first salvo exploded in perfect proximity to the incoming kamikaze, sending steel fragments through the aircraft's engine and control surfaces. Traditional anti-aircraft fire would have required multiple ranging shots to achieve accurate targeting, providing kamikaze pilots with warning and opportunity for evasive maneuvers. The psychological impact on Aoki was immediate and devastating. His aircraft had been damaged by the first enemy shells fired, demonstrating accuracy that exceeded anything in his training or experience. Japanese pilots had been taught that American anti-aircraft fire was ineffective against determined attack, requiring sustained exposure to defensive guns before achieving lethal hits. The proximity fuse technology eliminated this assumption by achieving immediate effectiveness that made survival unlikely regardless of pilot skill or aircraft performance. Aoki fought his damaged Zero through a series of evasive maneuvers while attempting to line up for his final attack run against Laffey. But the destroyer's defensive systems included multiple 40mm and 20mm anti-aircraft guns that created overlapping fields of fire around the vessel. The smaller weapons used conventional ammunition but achieved effectiveness through volume of fire that filled the air around attacking aircraft with steel projectiles. The combination of long-range 5-inch guns with proximity fuses and short-range automatic weapons created defensive coverage that extended from maximum detection range down to point-blank distance. Kamikaze pilots faced continuous anti-aircraft fire throughout their approach, with weapon systems optimized for different engagement ranges, ensuring that no gaps existed in the destroyer's defensive umbrella. As Aoki committed to his final dive toward Laffey, additional kamikaze aircraft from his formation approached the destroyer from different angles, creating the coordinated attack that Japanese tactics called for overwhelming isolated American vessels. But the radar Picket destroyer was not operating alone. Combat air patrol fighters directed by the destroyer's fighter control team engaged incoming kamikazes, while the ship's guns concentrated on the most immediate threats. The integration of air and surface defenses represented tactical coordination that Japanese planners had not encountered in previous campaigns. Radar Picket destroyers served as floating fighter direction centers that could coordinate defensive air patrols with surface anti-aircraft fire to create layered defenses that multiplied the effectiveness of individual weapon systems. Lieutenant Commander Robert Hagen, commanding the combat air patrol assigned to Radar Picket Station 1, received vectors from Laffey's Combat Information Center that directed his F-6F Hellcats toward specific kamikaze aircraft while the destroyer engaged others with gunfire. The coordination eliminated the confusion and target duplication that had sometimes degraded American defensive effectiveness in earlier engagements. The technological superiority extended beyond individual weapons to encompass communication and coordination systems that enabled real-time tactical adaptation. Radar tracking provided continuous updates on kamikaze positions and courses, allowing defensive commanders to allocate resources efficiently and concentrate firepower against the most dangerous threats. Aoki's Zero absorbed multiple hits from Laffey's 40mm guns as he descended through his final attack dive, but the aircraft remained controllable despite damage to non-essential systems, Kamikaze pilots had been trained to press their attacks even with heavily damaged aircraft, understanding that only complete destruction of their plane would prevent them from reaching their target. But the proximity fuse technology that armed Laffey's 5-inch guns provided capabilities that conventional damage assessment could not predict. As Aoki's Zero approached to within 800 meters of the destroyer, a proximity-fused shell detonated directly alongside his aircraft. The carefully calculated airburst sent steel fragments through the Zero's fuel tanks and control cables, triggering an explosion that vaporized the aircraft before it could complete its attack run. The mathematical precision of the proximity fuse detonation represented engineering achievement that exceeded Japanese technological capabilities by generations. The miniaturized radar components required manufacturing tolerances and electronic sophistication that Japanese industry could not duplicate with available resources. The technology gap demonstrated American scientific and industrial advantages that affected all aspects of modern warfare. Commander Becton watched Aoki's Zero disintegrate 600 meters from Laffey's hull, understanding that the proximity fuse technology had provided his destroyer with defensive capabilities that rendered individual kamikaze attacks nearly ineffective. But the battle was far from over. Intelligence reports indicated that Operation Kikusui No. 1 would involve hundreds of kamikaze aircraft attacking in coordinated waves designed to overwhelm American defenses through sheer numbers. The radar picket system had been designed to handle exactly this type of mass attack by distributing defensive responsibilities among multiple stations while maintaining communication and coordination between all elements. As additional kamikaze formations appeared on radar screens throughout the picket line, American commanders prepared to test their defensive innovations against the largest suicide attack in naval history. USS Bush at Radar Picket Station 1, USS Colquhoun at Radar Picket Station 2, and USS Cass and Young at Radar Picket Station 3 found themselves facing similar attacks as kamikaze pilots discovered the picket destroyer line and committed to attacking these isolated vessels rather than attempting to penetrate further toward the main American fleet. The Japanese tactical decision played directly into American defensive planning by concentrating attacks against the most heavily defended positions. Lieutenant Saburo Nakamura, leading another element of the kamikaze formation, approached USS Bush with the understanding that his attack represented Japan's best hope for inflicting decisive damage on American naval forces. The Special Attack Corps had been promised that suicide tactics would achieve results that conventional bombing could not, sinking enough American vessels to force reconsideration of the invasion strategy. But Bush demonstrated defensive capabilities that challenged Nakamura's expectations about American destroyer vulnerability. The vessel's SK radar detected his approach at 75 miles range, providing time for fighter direction teams to vector combat air patrol aircraft toward the incoming threat, while the destroyer's guns prepared for action at maximum range. The early detection eliminated the element of surprise that kamikaze tactics relied upon for success. Nakamura found himself engaged by American fighters while still 30 miles from his target, forcing defensive maneuvering that reduced his ability to maintain formation integrity and coordinate timing with other kamikaze pilots. Previous suicide attacks had achieved success by approaching American fleets undetected and attacking in coordinated groups that overwhelmed defensive fire through simultaneous arrival. Commander Roland Smoot, commanding Bush, opened fire with 5-inch proximity-fused shells at maximum effective range, achieving immediate bracket accuracy that demonstrated the radar fire control capabilities integrated with the destroyer's weapons systems. The proximity fuses eliminated the ranging shots normally required for accurate anti-aircraft fire, providing first-round effectiveness that previous American defensive arrangements had not achieved. Nakamura's Zero took hits from the initial defensive salvo, proximity-fused shells detonating close enough to send steel fragments through the aircraft's wing surfaces and engine cowling. The damage degraded flight performance and forced the pilot to compensate for control difficulties while maintaining his attack approach. Japanese pilots had been trained to continue their missions despite battle damage, but the precision of American anti-aircraft fire was creating damage levels that challenged aircraft survivability. The psychological pressure on kamikaze pilots extended beyond physical damage to their aircraft. The accuracy and immediate effectiveness of proximity-fuse anti-aircraft fire created stress levels that affected pilot performance during the critical final moments of suicide attacks. Pilots who had expected to face ineffective defensive fire found themselves under precisely aimed bombardment from the moment they approached American vessels. As Bush engaged Nakamura's formation, additional kamikaze aircraft approached from different vectors, creating the multi-directional attack that Japanese doctrine called for overwhelming isolated enemy vessels. But the radar picket destroyer was coordinating its defense with combat air patrol fighters and neighboring picket stations, creating integrated coverage that multiplied individual defensive capabilities. The combat air patrol assigned to Bush included 4 F-6F Hellcats equipped with radar and directed by the destroyer's fighter control team toward specific incoming targets. The fighters engaged kamikaze aircraft at distances that prevented coordinated attack timing, while the destroyer's guns concentrated on the most immediate threats. The layered defense created engagement zones that forced kamikaze pilots to fight through multiple defensive systems before reaching attack positions. Lieutenant Hiroshi Tanaka, piloting another Zero in Nakamura's formation, experienced the full effectiveness of American defensive integration when his aircraft was engaged simultaneously by fighter opposition and destroyer anti-aircraft fire. The coordination eliminated escape routes and forced kamikaze pilots into tactical situations where survival was impossible regardless of pilot skill or aircraft performance. Tanaka's Zero absorbed hits from multiple weapon systems as he attempted to reach Bush through concentrated defensive fire. 50 caliber machine gun rounds from attacking Hellcats damaged his engine, while 40mm shells from the destroyer's close-in weapons created additional damage that degraded aircraft control. The cumulative effect rendered his aircraft incapable of precise attack even if he survived to reach the target. The proximity fuse technology that armed Bush's 5-inch guns provided the decisive defensive advantage that terminated Tanaka's attack. A proximity-fused shell detonated 50 meters from his Zero, creating an airburst that sent steel fragments through the aircraft's fuel system and triggered an explosion that destroyed the plane instantly. The precision timing of the detonation demonstrated computer-calculated effectiveness that human gunners could not achieve through manual fire control. USS Colquhoun at Radar Picket Station 2 faced similar coordinated attacks as kamikaze pilots committed to attacking the picket destroyer line rather than attempting penetration toward the main American fleet. Commander George Wilson, commanding Colquhoun, understood that his destroyer represented an expendable asset whose sacrifice would protect higher-value targets concentrated around the invasion beaches. The tactical doctrine accepted radar picket destroyer losses as necessary costs for maintaining early warning coverage and forcing kamikaze attacks against heavily defended positions rather than vulnerable transport vessels. The destroyers were equipped with the best available defensive systems and supported by combat air patrol fighters, but their isolated positions made them attractive targets for suicide attacks. Wilson opened fire on approaching kamikaze aircraft using proximity-fused 5-inch shells that achieved immediate effectiveness against targets that conventional anti-aircraft fire would have required sustained engagement to destroy. The technology provided his destroyer with defensive capabilities that exceeded those available to larger vessels equipped with older fire control systems. But the sheer number of attacking aircraft overwhelmed even the most advanced defensive systems. Operation Kikusui No. 1 involved over 700 kamikaze aircraft attacking in coordinated waves designed to saturate American defenses through numerical superiority. Individual radar picket destroyers faced dozens of simultaneous attackers that exceeded their engagement capacity despite technological advantages. Colquhoun survived multiple kamikaze strikes before succumbing to accumulated damage that rendered the vessel unseaworthy. The destroyer's sacrifice provided crucial early warning that enabled the main American fleet to prepare defenses and vector fighter reinforcements toward the remaining kamikaze formations. The radar picket system had functioned as designed, absorbing the initial attack impact while preserving higher-value targets. USS Laffey became the symbol of radar picket destroyer defensive effectiveness when the vessel survived what may have been the most intense kamikaze attack of the Pacific War. Commander Beckton's destroyer faced 22 attacking aircraft during an 80-minute engagement that tested every aspect of American defensive technology and crew training under the most extreme conditions. The battle demonstrated both the capabilities and limitations of radar picket destroyer defenses. Laffey's proximity-fused 5-inch guns destroyed multiple attacking aircraft with single well-placed shots, while the vessel's 40mm and 20mm weapons created defensive barrages that forced kamikaze pilots into unfavorable attack angles. The integrated defensive systems provided protection that enabled the destroyer to survive attacks that would have sunk vessels equipped with conventional anti-aircraft weapons. But the sustained assault also revealed that even the most advanced defensive technologies could be overwhelmed by sufficient numbers of determined attackers. Laffey absorbed hits from multiple kamikaze aircraft and bombs while continuing to fight, demonstrating both the effectiveness of American damage control procedures and the limitations of defensive fire against mass suicide attacks. The psychological impact on Japanese kamikaze pilots extended throughout the remaining formations as reports of American defensive effectiveness reached other Special Attack Corps units. Pilots who had expected to face vulnerable isolated targets discovered instead that radar picket destroyers were equipped with revolutionary defensive technologies that made survival unlikely even for the most skilled aviators. Captain Minoru Genda, one of Japan's most innovative naval tacticians, analyzed intelligence reports from Operation Kikusui No. 1 that described American defensive capabilities beyond Japanese technological understanding. The radar picket destroyer system represented integration of advanced electronics, precision weapons, and tactical coordination that demonstrated American scientific and industrial superiority in fields critical to modern naval warfare. The proximity fuse technology that provided radar picket destroyers with their defensive effectiveness was particularly disturbing to Japanese technical specialists, who understood the engineering challenges involved in creating miniaturized radar systems robust enough to function in artillery shells. The manufacturing precision and electronic sophistication required for such devices exceeded Japanese capabilities by significant margins. Genda's tactical assessment concluded that American radar picket destroyer defenses had fundamentally altered the effectiveness of kamikaze attacks by eliminating the surprise and coordination advantages that suicide tactics depended upon for success. The early warning provided by radar detection combined with proximity fuse anti-aircraft effectiveness created defensive systems that Japanese forces could not overcome through conventional tactical adaptations. The strategic implications extended beyond immediate battle results to broader questions about technological competition between Japanese and American military systems. The radar picket destroyer concept demonstrated American ability to develop and deploy advanced defensive technologies in quantities sufficient for fleet-wide implementation, revealing industrial capabilities that Japanese planners had underestimated. Admiral Mato Magaki, commanding the 5th Air Fleet responsible for kamikaze operations, received reports describing American defensive innovations that challenged fundamental assumptions about suicide attack effectiveness. The radar picket system had not only detected and engaged kamikaze formations but had done so with accuracy that suggested technological advances beyond Japanese comprehension. Agaki's operational assessment acknowledged that American radar picket destroyers had created defensive capabilities that reduced kamikaze effectiveness while preserving the main invasion fleet from significant damage. The Special Attack Corps had expended hundreds of aircraft and irreplaceable pilots while achieving limited strategic results against targets that represented only a small fraction of total American naval strength. The technological shock experienced by Japanese forces extended to understanding of American manufacturing capabilities that could produce proximity fuses in quantities sufficient for routine use against individual aircraft. The electronic components required for each fuse represented precision manufacturing that Japanese industry could not duplicate, revealing scientific and technical gaps that affected all aspects of military competition. Lieutenant Commander Joseph Aulick, commanding USS Evans during the destroyer's legendary battle against 156 kamikaze aircraft, demonstrated the tactical effectiveness of radar picket destroyer defenses when properly coordinated with fighter support and neighboring vessels. Evans and USS Hadley fought off the massive attack while destroying 23 enemy aircraft and suffering severe damage but remaining afloat. The 90-minute engagement represented the ultimate test of American defensive technologies against the largest concentrated kamikaze attack ever mounted. The proximity fuse technology that armed both destroyers' 5-inch guns provided immediate effectiveness against attacking aircraft, while 40mm and 20mm weapons created defensive barrages that forced kamikaze pilots into unfavorable approach angles. The psychological pressure on kamikaze pilots during such sustained engagements was beyond anything experienced in conventional air combat. Pilots who had trained for single decisive attacks found themselves in extended battles against defensive systems that maintained accuracy and effectiveness throughout prolonged action. The proximity fuse technology eliminated the degradation in anti-aircraft effectiveness that normally occurred during sustained combat. The integration of radar detection, fighter direction, and precision anti-aircraft fire created defensive capabilities that exceeded the sum of individual components. Evans and Hadley demonstrated that radar picket destroyers could survive even the most determined kamikaze attacks when equipped with advanced defensive technologies and supported by adequate fighter coverage. The broader strategic impact of radar picket destroyer effectiveness became apparent as kamikaze attacks shifted toward targets of opportunity rather than coordinated strikes against specific objectives. Japanese pilots who survived encounters with picket destroyer defenses reported defensive capabilities that made planned attacks against protected targets nearly impossible to execute successfully. The technological superiority demonstrated by American radar picket destroyers influenced Japanese tactical planning for subsequent kamikaze operations. Special Attack Corps commanders acknowledged that proximity fuse anti-aircraft effectiveness and radar detection capabilities had eliminated many of the advantages that suicide tactics had initially provided against conventional American defenses. Captain Rikihei Inaguchi, staff officer for kamikaze operations, compiled after-action reports that described American defensive innovations beyond Japanese countermeasures. The radar picket destroyer system represented technological integration that challenged Japanese assumptions about achievable defensive effectiveness against determined suicide attacks. Inaguchi's analysis concluded that American proximity fuse technology and radar coordination had fundamentally altered the tactical balance between offensive and defensive capabilities in naval warfare. The scientific advances represented by these systems demonstrated American research and development capabilities that Japanese industry could not match despite maximum wartime production efforts. The psychological warfare implications were as significant as the tactical advantages. Japanese civilian populations who learned that kamikaze attacks were being defeated by American technological superiority understood that their military forces faced enemies whose scientific and industrial capabilities exceeded Japanese achievements in fields critical to modern warfare. The radar picket destroyer concept had achieved its strategic objectives by forcing kamikaze attacks against heavily defended positions while providing early warning that protected high-value targets from surprise assault. The technological innovations that made this possible represented American scientific achievements that influenced all subsequent naval warfare development. As the Battle of Okinawa continued through the spring and summer of 1945, radar picket destroyers equipped with proximity fuse anti-aircraft weapons continued to demonstrate defensive effectiveness that reduced kamikaze attack success rates while protecting the main American invasion fleet from significant damage. The technological shock experienced by Japanese kamikaze pilots reflected broader American advantages in electronic warfare and precision manufacturing that determined the ultimate outcome of the Pacific War. The legacy of radar picket destroyer operations extended beyond immediate tactical results to influence post-war understanding of technology's role in naval warfare. The proximity fuse technology and radar integration that provided these vessels with their defensive capabilities represented scientific advances that continued to shape military development for decades after the conflict ended. In the final analysis, the shock experienced by Japanese kamikaze pilots when they encountered American radar picket destroyer defenses revealed the extent of technological superiority that American science and industry had achieved by 1945. The defensive systems that made radar picket operations possible demonstrated capabilities that Japanese forces could neither duplicate nor effectively counter, providing clear evidence of the scientific and manufacturing advantages that would determine the war's outcome.